spectrometer takes advantage of ultraviolet and visible radiation to obtain information about the UV and the color properties of your solid or liquid samples. A deuterium lamp source is what will provide the energy to the sample. A monochromator is also used to separate the wavelengths. Your sample holders can vary depending on if it's a liquid or a solid sample, but the detector is going to always display the intensity absorbed at each wavelength. So you will get data very similar to what is shown on this slide. In a instrument that liquid samples are analyzed, this is a double beam instrument so that a reference cell and a sample cell are both used. The reference and sample cells look very similar to the quartz cuvette that's shown in the top right-hand corner of this slide. And methyl alcohol is used as a reference to more or less take a background from the instrument itself. If the sample is a solid sample, a single optical path is used, and the samples may either be placed on a salt plate, and then a background is taken and subtracted from the sample itself. An X-ray fluorescence spectrometer takes advantage of X-ray radiation to obtain elemental information about the various samples. So an X-ray tube is what's going to supply the radiation to the sample itself. Depending on the instruments, your sample holders can change slightly, and also depending on the sample, different filters can be used to optimize the energy levels. If you know you're looking for a certain element, the filters can optimize your data results that you obtain. The detectors are going to measure the intensity of the excited photons as they return to the normal state. And then a recorder is going to give you data that is very similar to what is shown on this slide. There is also an X-ray diffraction spectrometer that also uses X-ray radiation and can give you information about the elemental composition of samples. This is a little more specific information. Besides just the elemental composition, it also gives you information on the characteristics of the crystalline properties of that sample itself. But it also uses an X-ray tube to provide the X-ray radiation energy. It has a goniometer and a detector that allows the sample to be measured at different angles. It actually rotates around the sample itself during the analysis process. And then your recorder is going to display information very similar to what is shown on this slide, showing the energy intensities at the various angles that the sample is being hit with that radiation. An atomic absorption spectrometer can also be used to emit specific wavelengths of light to your samples to also determine various elements that may be present. The source is going to be different energy tubes that supply a very specific radiation wavelength. So you choose the tubes according to the elements that you're wanting to actually determine the presence of. The samples are vaporized in a flame furnace, and then there is a detector that measures the intensity of that element for which you are testing. The recorder is going to display the data in a graph, and then you also get a numerical value of the quantity of that element that's present. The final instrument is an inductively coupled plasma emission spectrometer that measures the light energy emitted by the excited atoms. In this instrument, an argon torch or a laser is used to vaporize the sample itself. The detector is going to measure the intensity of the element by characterizing the charged particles that emit light when the interaction between that torch and the sample occurs. And then your data is going to display the quantity of that element present. These are the various techniques that are used in a forensic lab, and this concludes our lectures for Module 2.